In this lesson, we are going to learn about basic concepts on your alternating current. Okay, so we know in alternating current, my current is not constant, rather it is a function of time. Okay, so my current basically varies with respect to time. Okay, so first we are going to see how AC is generated. Okay, so for that, let's just say I have a coil which is rotating in a fixed magnetic field. Okay, so let's just say this is my given configuration. Okay, so I have a magnetic field which is from north to south. Okay, my magnetic field is constant. Okay, it's like this, and I have a rectangular coil which you can see over here, which is rotating. Let's just say it is rotating like this. Okay, so it is rotating clockwise. Okay, so if you look at this shaded area, after it has rotated to a certain angle, it basically comes out like this. Okay, then after further rotation, it basically comes out like this. Okay, and still after further rotation, it basically comes out like this. And if now it rotates further, it basically arrives at its initial position. Okay, so this coil is rotating in a constant magnetic field. Okay, we know my phi is equal to B dot A. Okay, or in other words, it is BA cos theta, right? Now EMF is generated whenever my flux changes with respect to time. Okay, in this particular case, or in this particular scenario that we are seeing over here, my magnetic field is constant. Okay, my area of the loop, which is this area, is also constant. However, what's happening is your angle theta, which is the angle between your magnetic field and normal vector to the area, that angle is constantly varying. Okay, and hence what you're going to get is a induced EMF in this particular coil. Okay, so that EMF would result in a current that can be taken out, and you can have your, let's say, bulb connected over here and it would glow. Okay, let's just say what you're seeing over here is your initial configuration. Okay, this particular diagram, let's just say this is your diagram number 1, is your initial configuration. Okay, so this is at t is equal to 0. Okay, so at this point your magnetic field is like this, right? And your vector perpendicular to this area is also like this. Okay, so at this point your theta is equal to 0. Okay, the angle between your area vector and your magnetic field vector is 0. Okay, so at that time you are going to have your maximum flux. Okay, your maximum flux, phi max, is simply going to be B into A, which is corresponding to this configuration of your coil. Okay, now at a certain time t, okay, your coil is going to rotate by a certain degree, right? Let's just say your coil is rotating with an angular velocity of omega radians per second. Okay, so at a certain time t, what is the angle that this coil has rotated through? That angle is simply going to be omega into t, right? So the angular displacement of your coil at any given instant is simply going to be your angular velocity of the coil into your time. Okay, so instead of theta over here, I can say my phi is equal to B into A into cos of omega t. Okay, I know over here my induced EMF is d phi by dt. Therefore, I can say my induced EMF is equal to d by dt